Let's solve another problem. So we have that two farmers need to enclose a rectangular pasture containing 50,000 square meters. Suppose that along the road adjoining the property they want to use a more expensive fence, and that they need no fence on one side perpendicular to the road because there's a river that bounds the property on that side. So we're given that the expensive fence costs $20 per meter and the non-expensive one cost only $5 per meter. Then the question is, what are the dimensions of the rectangular field that will minimize the cost? To start this kind of problems, it's always recommended to draw a picture of the situation. So in this case, we're being told that there is a river and there is a road. And that we want to enclose a rectangular pasture here, right? So in this case, we will need only 3 sides, and one will be more expensive than the other two. So this one with red will be the expensive one, and let's say with green we will draw the other 2 sides. Okay, so this side will be X meters and it will cost $5 per meter. This one will be Y meters and it will cost also $5, and the red one will be X meters, but this one will cost $20. So this is the information we have, and we need to minimize the cost. So we have to find what are the values X and Y that minimize the cost of the fence. So first of all, let's write the cost of this fence. So the cost will be $20 times the X meters. This will be the cost of building this fence. Building this fence will cost $5 per meter, and the fence on the bottom will be 5 times X. So putting this together, this will cost $25 per times the X meters plus 5 times the Y meters. And again, we want to minimize this function, but the problem is that we have 2 variables involved. So we need to find some restrictions in our problem that allows us to write one of the variables in terms of the other. In this case, the restriction is that the area of the pasture has to be 50,000 square meters. That means that the area, which is equal to X times Y, has to be equal to 50,000. From this, we can obtain that Y is equal to 50,000 divided by X. Then putting this in our cost function, we obtain that the cost, depending now only on X, is equal to 25 times X plus 5 times 50,000 divided by X. And we want to minimize this function. So as always, the first step should be to find the critical values of this function, which is the derivative, in this case 25 minus 2,000 and 50,000 divided by X squared, and we want this to be equal to 0. To find this equal to 0, it is the same thing as doing 25 times X squared minus 250,000 equal to 0, and we can factor out the 25 and obtain that this is the same as x squared minus 10,000. So from this we obtain that x can be either equal to 100 or x can be equal to negative 100. We have another critical value which is 0, because the derivative is not defined when x is equal to 0. So the critical values here will be x equals negative 100, x equals 0, and x equals 100. Now that we found the critical values, we need to decide which of those are relevant to our problem. So of course the dimension of our pasture cannot be negative 100, and also it cannot be x equals 0. There is no way of enclosing an area if one of your dimensions is equal to 0. On the other hand, x equals 100 is a perfectly valid dimension we can use. Now we have to decide if x equals 100 is in fact the minimum we're looking for. So we need to check if c of 100 is the absolute minimum. Now to do so, we will use the second derivative test to check that it's a relative minimum, and we hope to see if the second derivative tells us more information about the function. So the second derivative of this function is equal to 500,000 divided by x cubed. And notice that this is positive when x is positive. So from this we find two things. The first one is that we have a relative minimum and c of x is concave up. So the shape of our function when x is positive looks something like this. And this point here is the relative minimum we found. So these two facts together implies that at 100 we found our absolute minimum. So going back to our problem, we need to find what are the dimensions of the rectangular field. So we found that x has to be equals to 100, and we had that y was 50,000 divided by 100. So that implies that y has to be equal to 500. So the dimensions are x equals 100 meters and y 500 meters. Those are the dimensions that will minimize your cost.